Looking at problem number 5, which says you have 45.3 moles of sodium iodide, which reacts with 34,800 grams of lead 2 nitrate in a double replacement reaction. How many grams of lead 2 iodide product are produced? So once again, we're going to start by writing our reaction. So we have sodium iodide, and it is reacting with lead 2, which means it has a +2 charge, and nitrate, which is NO3. So if they exchange charges, the nitrate's going to get a 2. And they are in a double replacement, so the lead and the sodium are going to exchange places to form lead iodide and sodium nitrate. Okay. If we're looking at this, we need to next balance it. So we have the same amount of sodium, but I have 2 iodides here, so I'm going to put a 2. So that gives me a 2 over here. I need to put a 2 to equal out my sodiums. That gives me 2 nitrates, but I'm good. I have 2 nitrates here, and my leads balance out. Okay. So we're balanced. So if we're writing what we have, we are given 45.3 moles. And this is really important because you'll notice you're in moles, which means you don't have to convert from grams to moles because you're starting at moles. Okay, so that's why it's really important that you write down what you have, because for this one, we have grams. Okay, so the problem's kind of trying to throw you off. You need to recognize what your units are. Okay, and we're looking at lead 2 iodide. So we're looking for grams of lead 2 iodide. So we do the same thing that we've constantly been doing. We're comparing our 2 reactants and figuring out who's going to make less product. And that's going to be our answer, whoever makes less, because that's our limiting reactant. But notice that since one's in moles and the other one's in grams, the problems or the conversions are going to look slightly different. So we're going to start with sodium iodide. We're going to write what we have, 45.3 moles of sodium iodide. We write what are given over 1. Okay. Since we're at moles, we can go straight into our mole ratio, which we're comparing moles of sodium iodide, and we're comparing it to moles of lead iodide. Okay. If we look at that, that's a 2-to-1 ratio. And then we're going to go from moles of lead iodide to grams of lead iodide. Okay, grams you're going to find from the periodic table, and you'll get 460.8 grams. If you do the math there, you'll get 10,437 grams of lead iodide are produced. Okay, if we look at our other reactant, in this one, we're starting out at grams of lead nitrate. So we write what we're given over 1. We have to convert grams to moles, so we'll do grams of lead iodide to 1 mole of, no, I said iodide, nitrate, I'm sorry. Okay. So grams, I'm going to get from the periodic table, and I get 331.2. Okay. Now that I have moles, I can go into my mole ratio, so moles of lead nitrate, now I get to say it, to moles of lead iodide. And if we look at our reaction, that's a 1-to-1 ratio. And then we can go from moles of lead iodide to grams of lead iodide. Periodic table, 460.8 to 1 mole. If we do that math, we will get 48,417 grams of lead iodide. So, and this is much smaller than this, so this is not our answer. Here is our answer. We also find out that sodium iodide was our limiting reactant.